Good evening, friends. So today we will discuss a new chapter which is called Work and Energy. So first of all, let us go by the introduction of this chapter. Let me give you some examples so that you can recall that whether whatever example I am giving, is it an example of real work done or not. Now see, work done can be of two types: mental work and physical work. If I talk about reading, learning, writing, doing everything regarding your study, whatever you are doing, it comes under the mental work. It comes under the mental work, which is actually, in terms of physics, we cannot define it. In terms of physics, the mental work is actually, it may be a work, but it is undefined in terms of physics. If you follow the mechanics, the mechanical world, they have no place for the mental work. Like reading, learning, watching TV, okay, observation. If you're doing some experiment and you are observing that means you are doing some mental work. And in terms of physics, that mental work has no place. But in place of that mental work, what we can actually define in terms of physics, it is the physical work. It is the physical work which can be defined under the physical circumstances. So let us give you some example of the physical work. Playing cricket, playing football, pulling something up, putting something down, they all are the examples of the physical work. And in our conscious or subconscious mind, also the day when we are awake, we do a lot of physical work. So in this chapter we will learn that whatever physical work we are doing, is that really we are doing the work in terms of physics? So this chapter will tell us whatever work we are doing, whether we are doing the actually work done or not. So now the question is, who does the work? The physical work we will define in this chapter, and physics can only define the physical work, the physical activities. Now my question is, who does the work? Is that we are doing something? If we are doing something, if your mother asks you to pull that bucket out of the well, and you are there, you pulled that bucket out of the well, so you said, okay mom, I have done the work. Have you really done the work? The answer will be given by the physics. And the physicist says, the classical mechanics says, we cannot do the work. We cannot do the work. I cannot do the work, you cannot do the work. The maximum thing we can do in order to get a work done, we can apply a force. That applied force will actually perform the work. Let me give you a same example. If your mom says, go and just pull the bucket out of the well, you have pulled the bucket out of the well, but the maximum thing you did is you applied the force against the gravity, and the bucket would be pulled out, and that's why the work is done. So that means you are not doing the work. The maximum thing what you did is you just applied the force against the gravity so that the work could be done. Okay, that applied force actually performs the work. We cannot, this is the main thing that we should understand. We cannot do the work. The maximum thing we can do is we can apply the force, and with respect to that applied force, if it is quite enough to do the work, it will perform the work. So who does the work? Neither I nor you or all the people in the world that we have, they cannot do the work. Physically, we can actually apply force. That applied force, I am telling you again, the applied force can only do the work. Applied force, if it is capable enough, then it will do the work, it will perform the work. I think it is quite clear. So as we cannot do the work, as to get a work done, we need to apply force. That means who will do the work? The applied force will do the work. If the applied force does the work, then in order to define work, we need that applied force to come into action. And work is defined in the frame of this applied force. You see, the definition of very work done is given as, in classical mechanics, if we follow, if we apply force causes the displacement of an object. If an applied force causes the displacement of an object along its direction, we can say that the applied force has performed a work. So every time when you apply some force, does it mean that the applied force is also doing some work every time? No, that does not mean that. As per the definition is concerned, if we apply force, suppose this is a pen and I am applying force, this is my point of application of the force. If I apply force in this direction, and after application of force, or as the force is applied on that object, if that object moved in the same direction to which? Same direction to the force applied, then we can say that that force, whatever we applied, that has performed a work. So that is the definition of work. Let us go to the mathematical equation of work done. Let us go to the mathematical equation of work done. Let us go to the mathematical equation. The equation of work done. In order to get the equation, we first know whether work is a scalar quantity or a vector quantity. Whether work is a scalar quantity or a vector quantity. Why we should know that I will come after that. Work, it is actually a manifestation of energy. When we will read about the unit of work done, then we will know the units of the energy and the unit of work done, they are similar, they are same. Okay, in CGS, in SI, they are same. So that's why we can say work is actually a manifestation of energy. And energy does not have a direction, it has only a magnitude. So that is why we can say the work is a scalar quantity. The work is a scalar quantity. It is not at all a vector quantity. As it is a scalar quantity, will it have a magnitude? Will it have a magnitude? Will it have a direction? Will it have a direction? As it is a scalar quantity, it will have a magnitude and will not have a direction. So it would be a scalar quantity. So now if we write the mathematical equation of work done, the work done is defined as, the force applied multiplied by the displacement. The force applied multiplied by the displacement. So what is work? Work is actually the product of force applied and the displacement. If you see, force applied, it is a vector quantity. And displacement, it is also a vector quantity. And work, it is a scalar quantity. You see, if we know what type of quantity it is and its mathematical expression, then we can only write the mathematical equation for the work done. You see here, the work done is a scalar product. It is a scalar quantity. And that scalar quantity is actually the product of two vector quantity. And we all know by the vector mechanics that we can learn in class 11 that if some scalar quantity is a product of two vector quantities, that means that scalar quantity has to be the dot product of that two vector quantities. Again I am saying this, as we know by the vector mechanics, this scalar quantity, if that scalar quantity is a product of two vector quantity, then we can say that this scalar quantity is actually the dot product, not the cross product, the dot product of these two vector quantities. And the equation will then arrive, okay, into our mind like this. W, if it is a dot product, this is a scalar quantity and it is a product of two vector quantity, and when we multiply two vector quantity, the product will only come as a scalar quantity if it is a dot product. That means work done is a dot product of force applied and displacement. if we write force as F, if we write displacement as S, then the dot product will be Fs cos theta, where F equals to force applied, S equals to displacement. And what is theta? Theta equals to the angle between two vectors. And what are those two vectors? Force vector and displacement vector. It is a force vector and this is a displacement vector. I think it is clear. Then we will move upon the unit of work done. Then we will move up to the unit of work done. The unit of work done. The unit. As we all know, work is actually the product of force into displacement. So the unit of work will be equals to the unit of force multiplied by unit of displacement. Is it as simple as that? It is as simple as that. So what will be the unit of force in SI? If we in SI system, if we see, the unit of force is Newton multiplied by the unit of displacement in SI is meter. So it is called the Newton meter, which is also known as joules. Which is also known as joule. What will be the unit in the CGS system? What will be the unit in the CGS method? The units of force in the CGS method is dyne into, it is a dot product, unit of displacement will be centimeters. Dyne centimeter, it can be written as dyne centimeter, and it is known as So that's all for me. This is the basic idea of the work done, and if you want to understand the work done in a very deep manner, we have to work out some of the mathematical problems in order to understand it. So thank you very much.